Hopefully you guys have had a really good week and are staying safe and healthy. Today is Thursday, April 23rd, and this is for Orange Coast College Critical Thinking, the 12:45 to 2:10 p.m. section. So welcome one and all. Be comfortable. Get yourselves ready to chill, and we'll just have a nice lecture today on chapter 12, which is all about science. Once it's 12:45 and class time is here, I'll go right into the notes and just have a few other basic, general reminders about the remaining dates on the schedule. So that's about it. Hopefully you guys are doing well. Just got my notes here, and I'm hanging in there, waiting until 12:45. But anybody at any time, of course, feel free to drop a comment, or if you have questions of any kind or anything else, I'm right here. I'm always happy to help. Awesome. I wonder how your guys' classes are going, how everything's going with the whole, change of normal operations. All I can do is speak for, my class and what I've done, but it seems like it's gone pretty well. Experiences with it, you think it's good, bad, or neither. All the feedback is helpful. So any interaction that we have, it's good for me, you, and everybody else. So just saying, never be shy. And if you need anything at all, I'm happy to help. So we still got like about 4 minutes till class time. So. Hey Dana, good to see you. Hope everybody's healthy and safe. I haven't heard any students yet say that they had any kind of health issues, so that's the number one thing. Hey Mark, good to see you. Cool. Hope you had a good birthday, by the way. Hey Wes, nice to see you too. Cool. Got a little group so far. Usually the numbers kind of jump up a little right at the time of class. Yeah, it's a weird birthday, right? Because it's like the same day that the lockdowns pretty much started. So I mean, we'll never forget. I wish I could never remember it, but never forget this 2020 birthday season, I guess, for us St. Patty's Day people. Okay. Which one's the best, It's not this one. Kobe. Cool. All right, just about another minute. So we'll be underway in just a second here. Hey there, nice to see you, Ruby. Cool. Good that we got a solid group already. And just taking a moment here and I'll be getting it going. Well, April 23rd, this is our 1245 to 210 class, Critical Thinking in Orange Coast. So first of all, everybody I think knows that today was the due date for the third homework, the one that had to do with finding fallacies in advertisements. So if you've already submitted that to me, hey Robert, if you've already submitted that to me, great, I've got it. If you have not, please do get it into me. I'm willing to accept it as an on-time submission if it's in my inbox today, but if it's coming tomorrow or later than that, then there'll start to be deductions for late work. So anyway, make sure to get it to me. It's an important part of your grade. It's 100 points possible for that homework assignment. That's just a quick reminder. Everyone should know it's due today, as noted in previous lectures and on Canvas. So, if anyone had any questions about that or anything else, happy to take them. But just wanted to start the meeting by mentioning that. Don't forget it's due today. I'm grading them, obviously, once this class is over, and I'll be working on them through the weekend. So they should be ready for you guys by Tuesday or so. And the next thing that's coming up after this is the third quiz. So the quiz that we'll take next is next Thursday, the 30th, a week from today. And that's a quiz on chapter 12, which is all about science. And we have 2 class periods that we're going to next Tuesday. That's on chapter 12. Then you have your quiz on next Thursday. After that, we're just going to be down to the last 2 things in the class. There's one more homework assignment that I'll give you guys after that quiz. And then there's the final exam. So, we're getting closer to the end, but we still have some important meetings to make sure we pay attention to. I know that this class and the whole semester obviously has been pretty disruptive for everybody, but the semester's not over, and you're still responsible for, trying your best to have a good result here. So, stick with it to the end. Don't quit when you're ahead. You have and do your best, and I'm sure you have a great result. Hey, Andrew, nice to see you too. Okay, so that was just me telling you guys a couple of quick basic facts about the remaining schedule. Nothing's changed. If you look at the syllabus, you could still use that syllabus to just see the schedule of dates for the remaining meetings. But while we're here and I'm talking to you through this live stream, I thought I would just make a mention of it. So yeah, next Thursday's quiz 3. After that, there's a 4th homework, and then the last day of class is Thursday the 20, what is that? Thursday 21st, and that's the date of the final exam. Okay, and we'll have review sessions and a study guide for that final, so you'll be well prepared for all those upcoming important dates and assignments. So I don't know, anything I didn't mention, anything that's not clear? If you ever do want to ask a question, I'm just inviting you to do that. I think it's always good for everybody. But if you have no questions for now, that's fine too. Just saying. Focus on these class lectures for the next 2 periods so that you can do well on this quiz next Thursday. Then we just have one more chapter after that in the book to look at, and that's chapter 9, which has to do with ethics. So chapter 12, chapter 9, those are the last 2. Chapter 12 is today's subject and also the subject of next Tuesday, the 28th. Chapter 12 is about the history of science, identify some of the basic assumptions that are made within science. Hi there. We'll study the steps of the scientific method. We'll try to understand what is the concept of pseudoscience, or in other words, just fake science, like stuff like, I don't know, palm reading, crystal balls, tarot cards, and all of that. So that's the goal, to get a good comprehensive overview of just the history of science, what some of its theories and hypotheses. All right, so before I go into the detailed notes, I just wanted to mention the stuff that's written in the beginning of the chapter by the editor. The editor makes mention at the beginning of chapter 12 about a current day scientific fact or discovery that really seems to be threatening our survival as a species into the future. And we're talking about global warming here. So the global warming phenomenon is something that is increasing over time, and it seems to pose bigger and bigger threats as time goes on. Why is that happening? Okay, well, industrial processes and the consumption that human beings have of certain fossil fuels create greenhouse gases, carbon emissions that accumulate in the Earth's atmosphere. And basically, they produce what's called a greenhouse effect. Now, a literal greenhouse is like, a setup where you're growing plants and stuff as a botanist within like this glass greenhouse that traps the heat and causes them to grow better in like a humid type condition. But when the whole planet is being kind of heated by the accumulating greenhouse gases in the atmosphere, it causes the planet's global temperature to slowly but gradually increase. And even if it's a small increase of a couple degrees, it makes a huge difference because it causes Arctic sea ice's effects, like, for example, rising sea level. When we've looked at the climate data over the past 100 years, we've noticed that the melting Arctic sea ice has actually caused global sea level to rise something on the order of 7 inches. And unless we have effective strategies to combat this problem, then the most reliable projections for the next century is that we could have as much as a foot of additional sea level rise by the end of this current 21st century, by 2100. Now, that's certainly a concern, right? Because that's going to affect coastal regions the most. And we, our institution is Costa Mesa, and, a lot of us, 60 years, you see the measurement of global temperature over that whole span. And it's kind of striking because the hottest 14 years ever recorded since we started this whole measurement process have all happened since the year 2000. And a lot of them have happened just over the past decade, since 2010 to 2020. So that's kind of disturbing, right? If you looked at a graph of global temperature, you'd see it spiking at the tail end of that timeline closer to our current day, which basically means that the trend seems to be accelerating. We keep hitting the hottest year ever. It seems like every year now. And water is rising because of that melting Arctic sea ice. And it's a little scary because in worst case scenarios, coastal regions like the places that we live could be underwater or significantly compromised by the ecological impact of the rising sea levels. For example, I was just at a big meeting for Orange Coast College before the lockdown, where all the faculty and stuff, we went into the big auditorium and they were giving a presentation about the possible consequences to Costa Mesa and other local areas in worst case scenarios where water level rises to a point that makes certain areas impassable or harder to access. So anyway, this is a class on critical thinking, and we want to be able, as good critical thinkers, to interpret and make sense of scientific information that we encounter from whatever source, whether it's scientific journals, whether it's put forward and promulgated in media. We want to be able to evaluate and assess the credibility and accuracy and strength of scientific claims and information that we find. So yes, we're going to learn about the history of science, identify some of its basic assumptions, study the scientific method, distinguish between real and junk science. It's just the topic of science. What does the word mean itself? Okay, so science. Our textbook offers us this, I think, pretty good definition. It's reasoning from observable facts to testable explanations for those facts. Okay, so we reason from observable facts to testable explanations for them. So that's the basic essence of what science is and what the practice of science is all about. In the world of science, we observe the world, first of all. We conduct observations of the world and we gather data about it. We then identify certain phenomena that we don't yet understand or can't explain why they occur. But we try and give an explanation. So scientists examine the world, observe it, see the things that are happening in it, and then try to give explanations that account for why those things are happening. So they're basically trying to identify cause-effect relationships. Something is observed to happen, and then the scientist's goal and mission is to try and give some rational explanation for why it happens. And this explanation that is given blew up. You want to take it a step further and understand why, though. Like, why does that happen? What's the cause? What's the basis for that happening? If you know why it happens, then you're able to, let's say, perhaps understand when it's likely to happen again or under what circumstances, right? So scientists want to understand the reasons that things happen in this world, not just the reasoning behind why that fact happens. And this explanation, again, the scientist doesn't just say, take my word for it, here's my explanation, and I'm not going to give you any way to check on it. They say, no, go ahead, don't take my word for it, test the explanation by performing an experiment. And this experiment will be able to verify and reconfirm the correctness of the explanation that was given. Okay, so we're trying to discover, observe events. We therefore try to give reasons which explain why they happened. And then we provide an experimental method which can be used to assess the credibility of that explanation. So that's what science is all about, and it's the major source and method that we have as human beings for discovering facts about reality. If you want to have knowledge about this world that you're a part of, whatever it is, from the largest to the smallest questions, science is the best place that you can go to get the most high quality answer. If you're interested in, why do plants grow? How does photosynthesis work? How does the weather cycle work? Why do volcanoes erupt? Why do hurricanes or earthquakes happen? Technological advancements that we've built function. If you want to understand those questions, the answers to those questions, science would be the best place for you to go in search of such an answer. So human beings looking for knowledge, trying to understand the world around them, science is the #1 tool that's going to give you the closest approach to good and accurate knowledge. So it's obviously huge, right? Without science, where would we be? We wouldn't have any of the technology that we take for granted. We wouldn't be having this lecture through these computer devices. We would not have telecommunications. We wouldn't have mass transit. We would not have global satellites, weapon systems. I mean, maybe that's not the best application of it, but we wouldn't have all the trappings of modernism that me and you take for granted every single day. So science is huge. We owe a great debt of gratitude towards it. That's why it's a major topic that we're studying here in this chapter. Okay, next thing is this. I want to tell you guys a little bit about some important figures in the early history of Western science. Okay, so these are there's many names that I could mention, but I'm going to talk about just 2 or 3 because they're talked about in the book. So, so one important man that is often mentioned in discussions of Western science and the so-called scientific revolution is this man whose name is Copernicus. Now his first name is Nicholas, so he's Nicholas Copernicus, but often just referred to by his last name in academic circles, right? So Copernicus, he lived from 1473 until 1543. And who was this man? So he was a Polish astronomer, and what he discovered was the heliocentric model of the solar system, which replaced the older geocentric model that was prevalent before him. So let me put that information here, and then we'll discuss that. So Polish astronomer, who discovered the heliocentric model of the solar system which replaced the geocentric model. Okay, Polish astronomer discovered the heliocentric model of the solar system that replaced the geocentric model. Okay, so let me think with you guys about what this really means then in more specific terms. Anybody have a guess, just based off common sense and your good vocabulary, what you think could be heliocentric? What do you think heliocentrism is? That's what Copernicus discovered. Sorry. Oops. In fact, our sun is in a random peripheral position in the bigger Milky Way galaxy, which it is a part of. In fact, it doesn't really make too much sense to talk about the center of the whole universe because it's constantly expanding and changing its contours. But you have the right idea here. He did discover that the sun is the center of our local cosmos, namely the solar system. So heliocentrism means sun-centered. Helios, sun, centrism, centered. Like earlier in the class, we talked about egocentrism or ethnocentrism, a person who thinks their race or their individualism is at the center of everything. Well, heliocentrism was the discovery that Copernicus was able to make, that the sun's at the middle, not geocentrism. So what do you think that means? Okay, Andrew, you already said it, I guess. The older geocentric model was the view that this Earth is the center of, well, they actually did believe that Earth was the center of the whole universe, but they had reasons because it was basically due to religious orthodoxy. So how did he discover this? All right, well, in the time that he lived, it's kind of like early Renaissance period, and there were these newly invented telescopes that gave, you know, human beings the ability to have more precise and powerful observations of the celestial orbits of planets around us and the sun. Copernicus was able to chart out and prove that actually, yes, the sun is at the center. Now, why was it so important? This guy's contribution, some people call it the Copernican revolution, like it's a revolutionary insight that the sun's at the middle, not the Earth. Why was that so significant? Okay, because you got to look at the bigger historical context. Throughout the entire early Christian era and the medieval period of, you know, the West, we're talking about from like year 0 up through pretty much like the 1400s, the church was the dominant institution in the West. It would jointly administer functions of the state, and it would also oversee elements of a person's education. So there was no such thing back then as like a separation of church and state. And if you held views that were considered unorthodox to church doctrine, then you could be punished, jailed, even executed. So to suggest that the Earth was not at the center was considered to be unorthodox and even heretical, because basically why do you think the church considered it so important that Earth would be placed in the middle? Because the belief was that God created this universe was deeply disturbing to the status quo at the time. But it's not just Copernicus who was in a way put under pressure by the doctrines of the church in discovering heliocentrism. Galileo, another very famous name, Italian scientist, he also used telescopes, and he discovered the same thing. He was forced to recant his testimony under penalty of or pressure of death. The church said, if you don't go into the public and tell everybody in the Vatican Square that these observations are fake and that they're inspired by the devil or something, if you don't go out and say that, then we're going to execute you. Even though he was in his 70s and he was going half blind from looking too much at the sun through the telescope, you know, they threatened him that way, so he recanted his testimony, but obviously he was correct. In subsequent centuries, the church has even issued formal apologies to Galileo and his descendants, because today everybody's on the same page and 100% of all people know, because it's definitively proven through much more powerful, you know, telescopes and satellites that we have, that yes, the sun's at the center, and the other planets, of course, all orbit reliably around the sun. But something as simple as that, an idea that we just take for granted as a given today, would have been considered so heretical and unorthodox just 500-600 years ago that people would have been, like elderly people, good pillars of the community, would have been threatened with execution if they didn't say that. Anyway, we're living in a different world now, and we owe a lot of gratitude towards Copernicus and the discovery that he made, because it opened the door to future and further scientific discoveries that obviously broke from tradition, because the church is not practicing a scientific method in discovering these facts. Okay, so that's Copernicus. Next, I want to talk to you guys just for a moment about Sir Francis Bacon, another important man in some of the early history of Western science. Okay, so another key figure to mention is Sir Francis Bacon. Sir Francis Bacon is a British citizen, but so you know, Sir Francis Bacon is the one who we can trace the invention or establishment of that method back to him. So he just did that. He established the scientific method. You guys probably maybe have some memories of it. It's a basic topic that's often taught, you know, in like high school and elementary school even. So it's the procedure where you start by identifying a problem in the, identifying an unexplained phenomenon in the world through observation, then trying to give a hypothesis which explains the occurrence of that phenomenon, and then developing some type of experiment which could test whether the hypothesis is correct or not. That basic procedure, which is the core of scientific practice, was first set forth by Sir Francis Bacon. And of course, we use that same method to this day. Nowadays, we have much more powerful tools to observe things with. We have microscopes, telescopes, electron, microscopes, and cloud chambers. We have a lot of tools at our disposal in order to conduct much more precise, observe the world, to identify some unexplained event. Then we try to explain why, and that's called making a hypothesis. After we have our hypothesis, we don't just say maybe that's true. We say no, let's test it. And if we can create a test which determines whether or not the hypothesis is correct, then we can see whether it's confirmed or not, and if it's Bacon for that. Okay, and I mean, living the world we're living in, right? Looking at a live stream on a computer, being able to just play video games, watch television, transport ourselves around in automobiles, orbit the planet, having global GPS satellites that allow us to navigate very easily. All these things, medicines, they all derive from the procedure of scientific research. So, these are towering figures really in the history of the West and just, the entire culture that we live in. It's well advised that we just kind of recognize the lasting and enduring value of what they've done for the world. Okay, so we go on then. The text describes these as like assumptions that are behind science. So what are some key basic assumptions that science as a field has to make in order for the practice to even, exist or get off the ground? We're talking now about baseline, fundamental, core assumptions that are built right into the heart of science. So, assumptions behind science. Okay. So first, the first assumption mentioned here is actually a concept that we've already talked about at least one time in our class this semester. So just coming back again, but it's the concept or assumption of what's called empiricism. Empiricism. So that's one of the basic assumptions of science, and we learned about this concept when we studied the knowledge chapter in our book some time ago, prior to the midterms. So this is the perspective that most human knowledge comes from a particular source. Maybe you have a memory. Go back in your memory or notes, whatever, or just common knowledge, and tell me, what does empiricism say? It says that most human knowledge comes from where? Tell me what that definition is. Empiricism. Most human knowledge comes from blank. What? Let's see what you had. Just a question. Yes, from the five senses and observation. Exactly. That's right. So I'll put it here. So most human knowledge. The five senses and observation. Of science, that most human knowledge comes from the five senses and observation. This is a core assumption of science because, as we see, the definition of science is to provide testable explanations for observed facts. So science starts with the observations of the facts, and then we try and use the tools that we have to explain the occurrence of those observed facts. So obviously, the assumption has to be made that we can get to knowledge by using observation with our five senses. If we couldn't know anything on the basis of what we can sense and perceive observationally, then science wouldn't work. Science is essentially based on and rooted in the idea of starting with what you can see, feel, taste, touch, or smell, and then using some type of hypothesis to make a credible explanation of those things that are observed. So science presupposes the value and importance of observation. Science doesn't just say, let's speculate about how things work. Let's just make stuff up in our heads sitting down in a chair and talk about it. No. The scientist says you have to collect data, you have to conduct observations, and then you'll be able to provide, let's say, explanations of the things which you have observed. But it's all about observation. If observation wouldn't lead us anywhere, then science would be futile. Science thinks that we can, in fact, learn things from the observations, our sight, taste, touch, hearing, and smell. Sometimes the observations are conducted by those standalone abilities of the human mind and body. Sometimes we have technological tools which allow us to enhance the ordinary capacity of our perception. So like if you do enhance, of course it is to enhance the quality of your auditory perception. So whether by means of our sense organs or tools which augment and enhance their capacities, we conduct observations of reality, and we think that we can discover knowledge about reality starting with those observations. That's what empiricism believes, and that's really deeply rooted in science. So yes, science does assume that most human knowledge comes from observation and the five senses, and that's why using the scientific method we can discover truth. Okay. Another core assumption of science is this idea of what is called objectivity. Okay, so next one, objectivity. Okay, so this concept is just the belief that we can learn about the world as it really is outside of our mind. Like we can learn about how it is, not just as it seems or appears, but how it actually is in and of itself. And that we can come to that correct understanding of reality without any bias. Okay, so this is the belief that we can learn about the world as it really is, and with no bias. Okay, so sometimes, again, it's useful, I think, in teaching to try and build a bridge from ideas and concepts that you already know to new things that you're just learning, okay? So I think probably most all of us have a general understanding of the distinction between objective and subjective statements. So let me see if we can kind of track this distinction. If I tell you that vanilla is the best ice cream flavor, what do you think? Is that an objective or a subjective statement? The statement that vanilla is the best ice cream. What do you think? Objective or subjective there? Okay, good, Andy. You're saying subjective. And same with you, Dana. Yes. Why do you say subjective? And that's correct. But just what would you say is the reason that that's your answer? It's subjective to say that vanilla is the best ice cream. Why? Why though? It is subjective. Can you tell me why? So, Andy, you say it's your favorite, maybe not the best. Even the concept of a best is itself something that I don't know if there's an objective answer when it comes to taste. And Andrew, you say it's opinion. Dana, you say it's our interpretation or perspective. That's all very good, okay? And you guys are right. So if I say vanilla is the best ice cream, I'm just speaking from a subjective point of view, meaning that I'm just speaking about what my own preferences and tastes are. But that's not an objective statement because it just depends on the individual, doesn't it? Another person may say, I don't like vanilla at all, and I find another flavor to be the best flavor. And we can both have our own differences of opinion because there's no objective fact, right, about what the right best flavor is. I mean, if you're talking to me, I really do like vanilla ice cream. I think it matches well with all kinds of other stuff, goes well with toppings and all that. But you know, if you don't agree with me on that, that's fine. It's not like I'm saying this is an objective fact. And there's no two ways about it. It has to be that. Okay, now, but what if I tell you that, I don't know, the moon is orbiting the planet Earth? Is this objective or subjective, that statement? That's a different statement. What do you think? Is that objective or is that just subjective? It's subjective, right? Yeah. Now, because it's just a basic objective fact. That's not just about how I'm feeling today or what my opinions are, right? That's just a fact. It has nothing to do with me at all. Even if I did not exist, right? There would still be the moon. It would still be orbiting the Earth. It was orbiting the Earth before I was born, and it will be orbiting the Earth after I'm gone. It's an objective fact. It doesn't depend on any subject's point of view. Okay, so science believes that we ourselves as humans can discover objective truth, that we can get to, oh, I see you, Andrew. For a minute, Andrew, I thought you were trying to, take us in a skeptical direction. Like, who knows? Are these claims really true? Is it just the opinion of the scientists? But I'm glad that you corrected it, because I don't want to have to go down in that rabbit hole. But yeah, let's just assume, right, that there are some objective facts, and that science anyway believes we can get to those facts, that we can really discover the things, not just how they appear to be, but how they actually are. So scientists don't think that we're just, when we do science, talking about our feelings inside and talking about our own opinions and preferences. The scientist believes that we are just being rational, and that we're just trying to get, and that we can get, to the objective answers about how this world is and how it works. So when a scientist gives a theory that they think is well proven, they don't just believe they're talking about their own mind and what they think. They believe that they're really talking about and getting to the truth of the objective world. Now, if there was no way to ever get to the objective facts, if we just thought science and everything else is just playing around with ideas and who knows if any of it's really objectively true, then what would really be the point, right? If science was just out there, but you said it's just a person's opinion if the science is correct, then it would be no better or worse than people just debating stuff at the water cooler with no evidence behind them, right? So science believes in the existence of an objective world, and there is an objective world. I mean, the world that you're in right now, it's not a big dream that you're having. It really exists outside your mind, and it has an objective, definite nature. So your goal as a scientist is not to do anything except to learn about that world and to learn about it as it really is. This is just the assumption that that's possible. It's the assumption that there's a way that we possibly can get to the objective truth if we're just rational and we use the proper methods. And that when we get to that truth, we're not just going to be speaking about our biases and prejudices, but that we're really just getting to the actual objective facts about reality. Okay? So science is a quest for facts and truth, objective facts, not just personal opinions and individual feelings and stuff like that. Okay, so hopefully that made some good sense. We're going to move on to the next basic assumption of science. Okay, and that is the concept of what's called materialism. Okay, so let me just clarify one thing before I go into the whole discussion of materialism. I want you guys to understand and know that this word, it has a different meaning outside of science and philosophy that has nothing to do with the way it's being described here. Remember way back when we talked, well, not too far back, but when we talked about the concept of equivocation, that fallacy of equivocation can happen because you can have a single word with different non-equivalent meanings, okay? Materialism is one of those words that has completely different meanings, and we're only interested in one of them, the scientific usage of the word. But in pop culture and everyday thought, the word materialism is sometimes used to refer to something like, who's a materialistic person? A person who only cares about their possessions, the way they look, the way people think about them in terms of their appearance. They want to always have the nicest things and kind of flex and all that. Like you might say, oh, that's materialistic. But we're not talking about materialism in that social sense. We're talking about it in the scientific and philosophical sense. So what it means in this context is something very specific. So it's the belief that everything in the universe is made out of physical matter, including us and our consciousness. So I'm going to put that up here. Everything in the universe is made out of, like literally built out of, physical matter. And there's a little more of this definition I'm going to still write, but I want to pause for a minute to ask you guys a quick question. When you think of physical matter, what do you believe is the word for the most minimal unit of matter? Okay, so if you broke matter down to smaller and smaller, size, what would be the least element of matter? The atom. That's right, Dana. So that's the word that's usually used to refer to the smallest bit of matter that there is. Now, in physics, we actually learned that there's subatomic particles and stuff, but let's just go with the classical term atom. This is originally from Greek. Atom, in its original meaning, has to do with not being. So the prefix a means not. Like if someone says, I don't know, the person's an atheist, means they're not a theist. So an atom is something that's not cuttable. Tom is the prefix from Old Greek for something that can be cut. So an atom is basically thought of as a segment of matter that cannot be further subdivided into smaller parts. Okay, so those things, the basic units of physical matter, are atoms. So I'm going to put that in parentheses here. It's just this view then. Everything in the universe is made out of physical matter. In other words, atoms. And then including us and our consciousness. So my cat, she's just so cute, and I really hate to do this, but I gotta make her go. I'm sorry, kitty, huh? Okay. Everything in the universe is made out of physical matter, including us and our consciousness. Okay, so that's the idea of scientific materialism. Has nothing to do with a desire to have a lot of nice possessions or whatever, okay? But that's the other meaning of it. That's the separate meaning, unrelated to this. So yeah, your question, is consciousness matter? Yeah, Mark, the view is that it is, according to this position. And Andy, I mean, that's a similar question. So yeah, let me just give you the explanation then. So according to materialism, everything is just made out of matter. Everything is, in other words, a material object. There's no such thing as a thing that is not physical. So on this viewpoint about reality, everything is just a bunch of atoms put together a certain way. What are you watching this lecture? You're a big collection of a ton of little atoms organized into living cells that form the human body and has the ability that you do have to perceive and have consciousness and to feel, right? But you're not really different than the table or the chair that's around you, in the sense that you're made out of atoms and so is it. So according to this position, consciousness itself, like consciousness, the ability to think, feel, hope, dream, perceive, have ideas, right? The inner life of the mental, that's all just made out of matter because it's all the brain. So a materialist, in the scientific sense, believes that there's nothing about consciousness that's different from the brain. So basically, your consciousness, your ability to watch this lecture and hear my voice, is simply a byproduct of the physical brain and its neurological processes. So, you have synapses and neurons in the brain. The way they interact electrochemically produces the consciousness that you have. You say it's depressing, I guess, because maybe if it's true, there's no soul, and there's no afterlife, there's no ghost in the machine. There's nothing that could survive the destruction of the body. They say, Kitty's crazy, they say ashes to ashes and dust to dust. So it's true that the human body's not immortal, and it does get returned to dust as it decomposes after you die. In this view of materialism, there's nothing more to you than your physical existence. So there's no soul that could possibly have a consciousness in a disembodied state. How could consciousness, according to this theory, exist if it's not attached to a functioning nervous system and brain? It's not like it can simply float free in a disembodied state, having no physical basis at all. So, that's materialism. It's an assumption of science. It cannot, I guess, ultimately be proven, because if there was a soul, right, if there is something that has no material substance, but it's consciousness, and it could somehow survive the destruction of the body, then that's something that is not capable of being observed because it is not an object that's got physical matter. So this is an assumption of science, but again, it's something that is just assumed as a given, can't necessarily be definitively proven. Andrew, you say this, what about concepts and thoughts? Are they matter-based? Yes. Yes, they are. According to this view, a thought that you have is the result of an electrochemical interaction between neurons and synapses in your brain. So if the brain doesn't exist, then there can't be consciousness. What's your question, huh? Is it, or is it not a question and it's just a sort of affirmation, like, huh, interesting. See, without seeing you in the class and hearing your voice, the context is hard to get. Did I say something that was not clear? And so you say, huh, because you want me to clarify? Okay, I got you, good, thanks, makes sense. So yeah, there's reasonable basis to believe materialism if you just think about it from a common sense point of view. Like take this marker that's in my hand, right? This marker, do you think it has consciousness? Like, do you think the marker is enjoying this lecture like me and you? I don't think so. And is it obvious why? I would think so, according to at least a scientific perspective. This marker doesn't hear or see or feel or taste or touch anything in the sense of having an experience because it doesn't have a brain and a nervous system. It doesn't have the physiological or physical basis to generate consciousness. But I do and you do. So how are we different from that marker? Isn't the obvious difference a physical difference? There's a brain, it's in your head, it has a capacity to function neurologically. And so where there's a brain, there's a consciousness. And where there's no brain, you have inanimate objects with no possibility to have consciousness. So how could a dead body without a functioning brain generate that consciousness? Or if you do have a soul that's immortal, how come you don't have memories of it existing prior to your birth? Wouldn't it have always been there? If it seems like your consciousness only comes online when you're born, wouldn't that also give credence to the thought that it's entirely based on your physical existence? Otherwise, what's going on? The soul's waiting for someone to be born and it says, okay, I picked that one, and then that'll be me. It's a strange idea. But anyway, you know, we're just going through some basic assumptions of science. Methodologically, scientific practice assumes this because if there was something that was like a mysterious soul or spirit, it would be paranormal, it would be supernatural, and therefore it would not be capable of being observed or tested on. So, you know, maybe it's not true. Maybe there really is this metaphysical soul that is nothing to do with your body, but science assumes otherwise, and materialism is what that means. Okay, so I'll go ahead and erase this and let Kitty stay here for a minute, but then I'll have to throw her down off the table again. So the next of these basic assumptions of science is the term, the text uses the term predictability. Okay. Okay, so what's going to be the definition of this? It's the idea that the universe overall is orderly and predictable, which means that established cause-effect relations will be repeatable and would hold forever. Okay, so Kitty, you're so cute. This kitty's just unbelievable to me, but don't be mad, girl. I gotta just ask you to go down here, huh? Okay. Predictability. Okay, so this is the belief that the world is orderly and predictable. Let me say in the broader sense, because I say world, someone's going to think I'm talking about the planet Earth. It's everything. So the universe is orderly and predictable. Meaning that established cause-effect relations will be repeatable and hold forever. So there we have our definition. No, it doesn't assume we've discovered everything already. No, that's a misunderstanding, Andrew. It's the idea that what we have discovered will continue to work in the same way as the future continues to go on, okay? Like here, I'll give you an example. So you see I'm holding the marker again, right? I'm holding this marker at a height above this table, right? and it's in my grasp, as you could clearly see right there. But I'm telling you that I'm going to do something. I'm going to open my grasp and release my grasp on this marker. Now, I have not done it yet, but let's try and see if you can make a prediction. What do you predict would happen if I release my grasp on this marker while I'm holding it over the table? Do you have a prediction about that? What do you think would happen? You heard my question, right? If I open my grasp on this marker, anybody have a prediction? Maybe a guess? What do you think would happen? Okay, Andy, you're saying it will drop. How sure are you about that? Could you put a percentage? How confident are you? You really think it's going to drop? Okay, you're dead certain. That's good. But I'm gonna please bear with me because I'm playing a little devil's advocate, okay? But like, how about I ask you this question? How do you know it's going to drop though? I haven't dropped it yet. What are you basing that on? What makes you so sure? What makes you so sure? I mean, you're telling me you're 100% sure, but why? Don't you have a reason? What makes you so sure that it's going to drop? Anybody? Because I feel like, yeah, you probably are pretty sure it's going to drop. That's easy, but what is the reason though? Like, why would you be so sure of that? I haven't even done it yet. So you're like predicting the future. How do you know it's going to happen that way? Okay, good. Past experiences. I see you saying force of gravity too, but I got to be a little bit more, I got to be a little tough on you right here, because when you say gravity, how do you know gravity is going to work today? It used to work before, okay. But how do you know it's going to work today, tomorrow, and the day after? Now, Andrew, you're saying historical evidence. And that's along the right lines, right? So basically, here's, I think, what's going on in your mind. I haven't dropped it yet, but here's your thought process. People have dropped objects before, and every single time before, they've always fallen when they dropped from a freestanding height. And that's how gravity appears to work. Now, Andrew, this is exactly kind of what I was going to try and play around with. Well, we know, sorry, let me see. I see your handle. I just want to make sure I'm getting your name again. Right here. I want to make sure I'm addressing the correct name. Sea Salt, that's your username. What's your name again in my class? Or I could just say Sea Salt, that's fine. But you can tell me or not tell me. But point I was making is this. We haven't seen me drop the marker yet. Cynthia, okay, perfect, thanks. You haven't seen me drop the marker yet, but you have a belief that it's going to fall when I drop it. And Andrew, you're kind of along the right lines of how I was kind of trying to sort of play devil's advocate. Like, gravity's worked this whole time, but maybe today's when it stops. Maybe April 23rd at 1:39 p.m. is when gravity shuts off, and a marker that you open your hand and drop, it doesn't drop. It floats and flies away. Maybe today's when that change happens, right? But you don't think that's going to actually happen. You don't think that that will change. So let's just test it. Ready? Wow, it actually fell. So your prediction was correct. Basically, the reason that you think that there's no way that that would not happen is because you believe we already understand the relationship of cause and effect concerning the law of gravity when objects are dropped from a certain height onto a massive surface of a planet like the planet Earth. You believe you've understood, and we've understood as human beings, that that's how gravity functions. And so we believe that how long is that going to keep working? If I had, let's say, infinite time, right? Wouldn't that be nice? But imagine I had unlimited time and I could just stand here giving you guys this live stream forever. That would be beautiful, but it's not going to happen. But if I could just sit here forever, dropping this marker perpetually, one after the other, and doing this for infinity of time, how many different times do you think it would keep falling? Now, I basically am leading you to the conclusion I want you to give, which is forever. You think that's going to keep happening forever. Why? Because you believe that the laws of nature are permanent, basically. You believe that the laws of nature, like gravity, entropy, that these are stable features of the universe that don't change over time. So if it's this situation now, it would be the same cause-effect relationship in 5 years, 10 years, a million years, a billion years, to infinity. Because these laws of nature we think that we're discovering are not just temporary laws for here and now, but for there and then, at any time and any place. Okay, Andrew, you say for your next class, tied with a nylon string and suspended from the ceiling. Now that would definitely scare people, right? But it's, anyway. My point is not to scare people, but rather to just inform about some important concepts of science. So you believe that this would continue to recur if I had unlimited time to continue to demonstrate. And if we had another closed physical system, which was physically duplicate of the Earth, right? Say we had another planet of about this size, and we had beings there or whatever, it doesn't need to be living beings, but conditions under which an object was released from some other object on that surface, don't you believe that the object would fall there as well? That it's not just that these laws apply on the Earth, or that they apply, for a few hundred or 1,000 years, but that they apply for all time and for all places. So if you go to the surface of the moon and you drop a pin, it should fall there, given the fact that there's the gravitational forces exerted by the moon's surface on the objects that are on that same surface. Okay, so that's an assumption of science, predictability. If we didn't have this assumption, then we would think, well, we don't really know. I mean, we built up theories of gravity, but maybe they'll just go out the window tomorrow, But science doesn't believe that's the way that the universe works. This universe works according to laws and principles that are permanent, that are universal. So what we know about the world today, we will know the same thing tomorrow and on into the future. It's not like we're going to say photosynthesis stops working that way at some future date, or gravity is going to stop operating in the typical way at some future time. Now, can we prove that it will always be that way? No, because we haven't been in the future yet. We're in the present. But the assumption, anyway, of science is that we don't have to wait for the outcome. We already have a safe and certain knowledge that those cause-effect relationships will persist. Okay, so that's the example of predictability. Now I have one more of these assumptions that is behind science before we move to the next unit of these notes. So the next and last one is what's called unity. Okay, so the scientific assumption of unity is this idea that it's the belief that there is an underlying integration and unity of all things in the universe. So there's an underlying unity of the universe such that everything can eventually be explained according to a single universal set of scientific laws. Okay, so there is an underlying unity to the universe such that everything can be explained according to a single set to a single universal set of scientific laws. Okay, so the assumption here is the assumption of unity, and it's that idea that you see written. The view here, the assumption is that the whole universe is one system that's unified. And since it is, that means that there should be one set of physical laws that can explain everything from the biggest to the smallest level of reality. Now, in fact, this is an assumption that science has, but it's kind of the projection of an unachieved goal of science. This is like an ultimate ambition of science, but we have not quite gotten there yet. The reason is because as of today, we have two different fields within science that explain two different levels of reality. So on the big levels, the macroscopic big scale of reality, talking about the behavior of planets, stars, massive objects, galaxies, galaxy superclusters. When it comes to that stuff, we use the Einsteinian theory of relativity, so relativistic physics. On the other hand, though, when we want to learn and know about the most infinitesimal microscopic levels of reality, like that's quantum physics. So the behavior of quantum particles and subatomic particles is governed by quantum theory. And the behavior of the macroscopic level of reality is governed by the relativistic theory, general and special theory of relativity. So for the big macroscopic, you've got relativity. For the little microscopic reality level, you've got quantum. And these actually two fields of explanation have contradictions at the margins. So they don't fully they're not consistent with each other. So the goal for future scientists and current day physicists is to eventually be able to build some kind of bridge between the two worlds of quantum theory and relativity. And if we get there, then we would have one comprehensive set of principles that explains everything, from the biggest events in the universe to the smallest little ones. Right now, we still don't have that, but scientists assume, as you see the word assumption, they assume that eventually we can get there. That's sometimes referred to by the acronym GUT, or Grand Unified Theory. If we have a grand unified theory at some future time, then we'll be able to explain everything that ever happens in the universe based on that overall unified theory of physics. Have we done it yet? No. But scientists assume that we will, and one of the main reasons they assume that is because since it's just one universe, shouldn't there just be one set of laws? It would be weird and perhaps not elegant for there to be two different sets of laws for one universe. One set of laws for the small stuff, and another set of laws for the big, grand, large-scale stuff. So even if we haven't quite gotten there yet, maybe over the next century, we will make progress towards this grand unified theory, and we will no longer have those discrepancies that currently exist between quantum and relativity. All right, so I've talked to you guys so far then about different assumptions that are bound up with science and they're built into it. The next part of the chapter 12 talks about different attitudes that people can have toward the relation of science and religion, okay? And it specifies 4 attitudes that a person can have about the relationship of science and religion. So we're going to talk about those now. Okay, so four possible views about the relation of science and religion. Okay, so science and religion, probably you've heard and you know that they don't always agree with each other, right? Much has been made of the idea that if you're like fully committed to scientific perspective on reality, then you would deny certain like religious claims. Or on the other hand, if you're really devoutly committed to a religious perspective on the world, then you might have to dismiss or reject certain scientific claims. People are not always sure what the options are for what attitude you could take concerning these apparent disagreements between science and religion, but we're going to try and make them very clear and spell them out. So one view is that when those two fields come into conflict, that maybe it's that you prefer science over the religious explanation. So one attitude or view is that science takes priority over religion when the two come into conflict. Now, the alternative to that, just the opposite basically, is to think that religion takes priority over science when the two conflict. Okay, so there's 4 total, but for now anyway, the board we have room for the first 2. So we're just going to talk about those first 2 for now and then see if we have time with the remaining part of class to go into the next 2. If not, we'll just pick up with that on Tuesday. But okay, so first of all, one view is this view. Some people might say if science and religion don't agree and they have a different claim on something, then science is the thing that you should defer to and just basically favor science when it comes into a conflict with religion. What could such a conflict be? I mean, there's all kinds of them, but like, you know, in some versions of religion, it says that Adam and Eve are the first two human beings created in God's image in the Garden of Eden. But of course, science says nothing like that is true. Human beings, of course, evolved according to a scientific account over a very large scale of time, gradually descending from greater apes. And it's not like there was just a single unit of two, but rather like the coming into being of the whole species at large. Or you could talk about the timeline of the universe. In Genesis, it says that God created the universe in 7 days, and the seventh day he rested. But according to science, that's far from true. It took billions of years just for matter to coalesce into stars and planets, and it took even more billions of years for life on the planet Earth to evolve into the sophisticated form that we are. You know, the initial conditions of the Earth, according to science, in the evolutionary perspective, you got a lot of microbial and single cellular life. And it took much longer for sophisticated life forms to specialize, diversify, have vertebrate and mammalian life. And we're at the tail end of that whole process, according to science. The science and religion seem to be saying opposite things here. One saying we were way back at the beginning, the other saying no, we're way at the end. The scientific account saying we're not created in God's image, but we evolved, and a creationist view of at least some religious perspectives saying that, you know, God made us in his image. And we could go on and on, you know, whether it's Noah's Ark and the flood, you know, scientific accounts to say that wasn't physically possible, or of course you couldn't have stored all the animals on such a vessel. When there are these conflicts, some people will say, well, I favor the scientific account there. So that's like to reject religion when it conflicts with science. On the other hand, though, some people will just take the opposite tack and would say, well, if religion and science don't agree on something, I'm going to prefer the religious explanation of things instead of the scientific one. So there's just different options for people. It's not my job to tell people what they should or shouldn't think about it, except just trying to be reasonable and critical. But for the most part, you know, people that are, let's say, scientific realists, secular type of people, they're going to probably prioritize science. Maybe a more devoutly religious type of individual might go in the second direction. And that's just a decision each person makes on their own, but now we sort of see the possibilities. And then there's two more views after this to mention, so let me put them up next. Okay, so there's also the idea or view that science and religion actually deal with different topics. So in that viewpoint, they don't really conflict because they're talking about separate things. They're in their own different lanes, as it were. So science and religion deal with different topics. And then a fourth and final possibility that's mentioned in the book is that maybe science and religion are actually compatible. So the apparent disagreement is really an illusion if you look at it the right way, or if you interpret maybe it the right way. They're not really saying different things. They agree. So that's the fourth and final idea, that science and religion are compatible. Okay, so different topics, or maybe compatible. So number 3, that view that's written there, that says that they're dealing with different topics. What could these different topics be? So somebody might deny that there's actually any conflict or confrontation between the two because they're relegated to their own separate realms. Maybe a person might think that when it comes to science, science is all about explaining physical reality, material processes, and cause-effect relationships. But when it comes to religion, that's all about spiritual stuff and the moral side of life. And since those two arenas really aren't in competition and they're totally separated, then they really are not stepping on each other's toes or bleeding into each other. Maybe the person who holds number 3 is thinking that if this is like a Venn diagram, there's not that overlapping part in the middle, but just two separate spheres of influence and importance. The religious sphere concerned with matters that have nothing to do with what the scientist discusses. That's a viewpoint that's possible, and some hold that view. But it's, I think, hard to completely wall these two things off from each other, because definitely, if you just study both, they seem to, in many cases, want to talk about the same topics. Science talks about the origins of mankind and the genesis of the universe. and so does religion. Just talking about a point mentioned earlier in today's lecture, is the universe geocentric, or is the solar system geocentric or heliocentric? The scientific and the religious answer at one time was different. And to just say, well, they're dealing with different topics, that would not have made much sense to somebody who's doing scientific research on the position of the Earth and being threatened with death by the church if they didn't change their findings. So I'm just saying that although 3 holds certain appeal, it is a little bit hard for us to completely disentangle the two things, because there's many different cases of scripture which at least appear on the surface to be talking about things that science is also talking about. Then number 4, that they're compatible. That's an interesting way to try and diffuse the appearance of conflict between the two. This is usually the option that people take when they try to reinterpret religious scripture to bring it into conformity with whatever the scientists are discovering. Maybe you've heard people try to finesse this type of compatibilism in your own life. Like, so take the case of the appearance of mankind in the universe. Did it happen billions of years after the universe started, or did it happen within the first 7 days? Now, it looks like science and religion are not on the same page there, because science says it did take billions of years, and the religious claims in Genesis are that it was all done in 7 days. How do you think somebody might try to, like, I don't know, reinterpret something there to make it seem like there's actually no disagreement between those two claims? Maybe a person might say, well, okay, well, really what the Bible was saying was, it said 7 days, but somebody might then think, that doesn't necessarily mean, or does mean, what do you think? How could somebody try to, if you get what I'm saying here, make it seem like the religious scripture doesn't even disagree with the scientific findings? How do you think that could be made, that case could be made? Got a lot of bright people in this room, so I'm definitely sure that you have a sense of this, so just tell me what you think. Well, there's no room, but in this universe, okay, in this universe of people that are in the class. So anyway, let me ask it again. If it did cut out, sorry for that. The question is this. We're looking at number 4, the position that science and religion are ultimately compatible with each other. And so when one person says that in religion it says the universe was created in 7 days, and mankind was already done within that 7 days, because on the 7th day God rested. But science says, no, we did not appear in 7 days at all. In fact, it took billions of years, that's much longer than 7 days, for humanity to ever appear in the universe. Is that a discrepancy? Somebody might say, and now Andrew, you're giving me the type of response I was looking for. Somebody might say, well, who knows what a day is? It's written as 7 days, but that could be just an arbitrary term to refer to whatever unit of time God actually took. So maybe a day, when it's spoken of in the Bible, refers to billions of years as measured by a human being, not 24 hours as observed in the typical course of the revolution of the Earth on its axis, showing different faces to the sun. So you kind of see what I'm saying? Somebody might try to reinterpret the biblical literalism to create space for the scientific accounts. Like, so if a scientist says there's evolution, and in the Bible it says, no, God created us in his image, maybe a sophisticated, nuanced type of person would say, well, God did create us in his own image, but he wanted to use evolution to get us to that point, and it took him billions of years, but they just didn't want to say it like that in the Bible. So you kind of understand what I'm pointing out? Like, some people, in fact, do that. They say, religion and science are not really so much disagreeing. It only looks that way because you're interpreting religion in a specific way. But I definitely find that that's somewhat subject to criticism, that approach. Because in my mind, anyway, it's kind of ad hoc. The religious interpretation is only relaxed or loosened or modified in the light of a scientific discovery that puts pressure on it. But nobody was thinking about, let's reconsider the meaning of the typical term day at a time in the past when there was no scientific discovery to contradict the writings of the Bible. It seems like it's only after the scientist brings their results forward that people then have to spin their wheels to try and think about how to make the religious claims consistent with it. So doesn't that seem, in a way, like a little arbitrary? I don't know. You could argue that. Let me give you an analogy. Suppose that I just randomly shoot an arrow at the side of a barn with no aim at all, and it just hits a random point on the barn. Now I go up to wherever the arrow is, and I draw a bullseye around it. Now it looks like I hit the bullseye, right? But am I some skilled marksman in that case? No, I'm just drawing the target around wherever the arrow lands. And so when a scientist discovers, here's something that contradicts traditional religion, and the religion says, well, no, that's what we meant all along, it kind of seems like it's, covering up for the fact that that was not the most natural interpretation to apply at the outset, and only now, subsequent to some kind of intellectual pressure that's being exerted on it by scientific discovery, new interpretations are being advanced and offered. It seems like it's just convenient that you can just make it mean whatever it has to mean, so that the scientists and the religious claims never seem to contradict. So anyway, these are the 4 possible views that people really do take when it comes to science and religion. They basically boil down to these 4 options. Go with science when there's a disagreement, go with religion when there's a disagreement, claim that they're not even on the same subject matter, or say that, well, if you really look at it closely enough, there's a way of interpreting those religious claims that makes sense with what the scientist says. And whichever view you have, there's obviously many possibilities to take, but it's good to kind of be able to assess it in comparison with other available attitudes that others might take. And it's good to just, have the knowledge of what the menu of possibilities are for an average person. So yeah, that's about it for today, right? I wanted to go into chapter 12, start off and tell you guys a little bit about science and some of the notes, but there's more. I want to save some of it. I know 2:10 is our official class time, but I want to kind of have balance so that the 2 meetings on science are approximately the equal length. So we'll just pick up from here on Tuesday when we come back, Tuesday the 28th after the weekend. We'll go over the scientific method. We'll talk about qualities of a good scientific hypothesis, and we'll talk about science and pseudoscience. So that's what's left for chapter 12, but we're halfway through it. And the quiz on chapter 12, which is your next, graded assignment, that is next Thursday, a week from today. So, make sure you read the chapter, try to catch the lecture on Tuesday as well as today, obviously, and then we'll take our quiz next Thursday and getting close to the end of the semester. All right, well, thanks, everybody. Thanks, Andy, for your nice comments, and have a great weekend, guys. Stay safe, stay healthy, and I'll definitely catch up with you then after the weekend. Okay, bye-bye.